All right, so the next video here is going to be about how we are going to use this information, that is Venn diagrams and the square of opposition, in order to enable us to determine if an argument is valid or invalid, right? So we've already experienced in the class how we've looked at some short arguments and tried to decide, are they valid or invalid? And that can be a challenge. Sometimes you can kind of intuitively see, yes, if the premises are true, then the conclusion will be guaranteed to be true. But the rest of this course will be working toward coming up with basically procedures we can go through to determine if an argument is valid or invalid. So it's not so, hit and miss, not such trial and error in terms of determining if an argument is valid or invalid. And so here in this section, we're going to be looking at what are called immediate inferences, which, as you can see here, are arguments with one premise. And we have an example here, right? It is false that all cows are punctilious creatures. Thus, it is false that some cows are not punctilious creatures. And the reason I've used that word punctilious here is to sort of, you could say, dazzle you a little bit, right? Make it so it's not clear if this is a valid or invalid argument, since we might not know what exactly is being discussed here. All right, and so you're going to see this on the exam one, right? And so what you are going to do with this is you are going to, first of all, use Venn diagrams to determine if this is a valid or invalid argument. And so what you will do is you will draw a Venn diagram for the premise. Okay, so there's the premise. And then you're going to draw a Venn diagram for the conclusion, all right? And so our premise then, which I hope you can see it here, is that it is false that all cows are punctilious creatures, right? And so what we have is we have our quantifier, all, and before that we have this it is false that. And you're going to see that on some of these arguments. And so I will just tell you the way to handle that is to set this idea of it is false that aside to begin with, and just focus on doing the Venn diagram in this case for all cows are punctilious creatures. And so what that means is that we are going to have our subject term, right, comes after the quantifier, cows, and I'll just put a C there. And then we have as our predicate term, punctilious creatures, so I'll put a P there. Now, the next point is extremely important. What you need to remember to do is once you label your premise diagram in a particular way, with cows on the left in this case and punctilious creatures on the right, you need to immediately go ahead and label your conclusion Venn diagram with the same thing, right? So cows on the left, punctilious creatures on the right. And of course, in this particular case, you might think, well, obviously you would do that, but I will tell you, and you'll see very shortly here, that sometimes that isn't necessarily the obvious thing you would do, but it is the necessary thing to do. The reason that you need to label these diagrams the same way is because to determine if this is a valid or invalid argument will require you to just basically compare the two pictures. If the pictures match, it's valid. If they don't match, it's invalid. And by the way, I have the answer here under this big black mark out at the bottom of the screen. It's kind of a scratch off here. We'll see how that works when I erase the answer, and we'll get to that. Okay, so having done that, we're going to go back to the premise. We want to diagram all cows are punctilious creatures, right? And so we remember this. All means if there are any cows at all, they've got to be punctilious creatures. And so as we saw in that earlier video, we've got to shade that area 1 here. Okay. Now, I said it is false that. We need to set that aside and not worry about it. That's not forever, of course. It doesn't go away. We need to account for this idea that it is false that all cows are punctilious creatures. But the good news is it's very easy to do this. It's very easy to account for this. So what you want to do is, if we're saying it's false, so this shading here, right, means that there's nothing in there. If it's false that there's nothing in that area, that, of course, means that there's something in that area. And so to account for the it is false that, we're simply going to erase the shading and put an X there, because an X means there is something in there. Okay? So that's sort of how you think through that, but the easier way to do this is that anytime when you have it is false that, you just draw the picture, right, so to speak, draw the picture for the premise, all cows are punctilious creatures, as we did, and then just flip the marking to the other one. That's all you have to worry about. Just flip the marking to the other one. which is what we just did. Okay, now we are going to go to the conclusion, and the conclusion says, let's take a look at this. It says, it is false that, right? So we're going to set that aside. So we're going to go ahead and worry about the rest of this. Some cows are not punctilious creatures. Okay, we're going to diagram that here on our right-hand Venn diagram. And so, again, we have cows on the left, punctilious creatures on the right, as we should. And so some, right, anytime you have the quantifier some, that means there is at least one. That means we're going to use the X. And so we're going to put an X in the cows circle, right, because it says some cows, but not in the punctilious creatures circle, and so we put it there, okay? Because that's a cow, but it's not a punctilious creature. But, just as we saw with the premise, we don't stop there when we have it is false that. When we have it is false that, we need to replace whatever marking we had, right, with the opposite. So in this case, replace the X with shading. Okay, so what we have here is a Venn diagram for the premise and a Venn diagram for the conclusion. What we can see in this picture is that they don't match, right? And so if the premise is true, we're not going to know if the conclusion is true or false because the conclusion is saying something different from the premise. And so, in fact, as we can see here, this is an invalid argument, all right? That's what we would say after doing these Venn diagrams. The pictures don't match. It is therefore invalid. Okay, so that's how you use Venn diagrams to determine if this is a valid or invalid argument. But we can also use, and we have to also use, the square of opposition when we can. And so when can you use the square of opposition to determine if an immediate inference is valid or invalid? You can use it when the subject and predicate terms match from the premise, cows, to the conclusion, punctilious creatures. So they're the same subject in the premise and the conclusion, and the same predicate in the premise and the conclusion. That means we can, in fact, use the square of opposition. All right, and so we're going to do that, and I'm just going to clean this up here real quick, and then we will do that. Okay. So just like being in a class together, right? I'm erasing the whiteboard, and you're watching me do that. And it's not the most exciting thing, but hey, it's okay. Okay, so now we're going to use the square of opposition to show if this is valid or invalid. We already know it's invalid, but hopefully our square of opposition will confirm that. We're going to draw the square of opposition, A, E, I, and O, and then you want to put these lines that indicate the contradictory relationships. Remember, as we saw in the previous video, the relationships around the side, the edge of the square of opposition don't matter. They're not guaranteed. These are the guaranteed relationships. And so now what you're going to do is, again, you look at the premise, and as we did before, you're going to set aside it is false that. And so we see that the premise is an A statement, right? All cows are punctilious creatures. And so we want to circle the A here, because that's the A statement. That is our premise. We put a P next to it because it's a premise. And then, just as we saw before, we're not going to forget about it is false that forever. We're going to indicate that this is being asserted as false, right? We're being told this is a false statement. Now, we go to the conclusion. Oh, we have another it is false that. So once again, we sort of sequester that, leave that off to the side. And so we're going to indicate on our square of opposition the conclusion. Some cows are not punctilious creatures. Is that an A, E, I, or O? Some are not is an O statement. And so that is our conclusion. And again, it is being asserted as false. So what we see here, this was what you're going to need to represent, or reproduce, I should say, on the exam one, when you're using the square of opposition to show if this argument is valid or invalid. You draw the square of opposition, you label the premise and the conclusion accordingly, and then you also label true or false accordingly. And since these truth values are not opposite, right, as they're supposed to be, that shows that this is invalid, right? Because the A statement is false, we would expect the corresponding O statement to be true, but it's being asserted as false, so this is definitely an invalid argument. All right, so we're going to practice that again here with another example in the next video.